To quote Ghostbusters 2, death is but a doorway. Time is but a window. I'll be back. Time is kind of a weird thing. And what's even weirder is the concept of geologic time. Come along with me while I take you to our newest geologic epoch. Everybody talks about time in terms of minutes or Doctor Who episodes or the amount of time it took HBO to actually produce and finish Game of Thrones. Yeah, that's right. That should be a measurement of time. Well, not my opinion, but whatever. So geologic time is actually a measurement of not just time itself, but the layers of rock based on major events in the geologic timescale. These events can be anything from climate shifting to the movement of continents, extinction events, and other globally recognized observable events that have occurred. The geologic timescale takes the concept of time and then applies it to strata. So you have two things standing side by side that you can use as a tool when you're trying to describe what you're seeing in geology and science in general. Lots of people use the geologic timescale. The geologic timescale covers 4.54 billion years. That's a lot of time. So we as humans live anywhere from 50 to 110, 120 years if we're really, really lucky. And that's nothing compared to the geologic timescale, which deals in billions and millions and thousands of years. Everybody's familiar with dinosaurs. So let me just use the dinosaurs as an example here. Did you know that the dinosaurs actually lived for millions of years? That's what we're talking about here. So humans have only lived for a couple 100,000 of years. We're not that old. We're kind of like the dust that you pick off your furniture when you really think about it, or in terms of Game of Thrones again, the 8 years that it took them to actually produce and finish the series is kind of like the dust left by Drogon at the end of the series when, King's Landing went up in smoke. Right. Everybody's talking about it. The internet ruined it for you already anyhow. But when you take that amount of time and you divide it by the layers of the earth, you get what are called chronostrata. So they are the layers of dirt that actually correspond with periods of time. So where are we? That's a good question. I feel like everybody has asked this question. Where am I? Where am I in my life? In this plane of existence? But no, really, where are we? So until very recently, and when I say recently, I mean the 70s, which doesn't feel recent, but again, remember we're talking about geologic time, so that is recent. As recent as that, we have suggested that we're actually in a different epoch than we started in the 1900s. So the 1900s are firmly in what's called the Holocene, and the Holocene is the prime period of human life. And then we came along and we're kind of like bad children and we do what we want and we've done a lot of things and our room is really messy right now. And that messy room has actually made scientists start to develop the idea that we're no longer in the Holocene. So a major event has occurred. What is that major event? Well, we'll get there. I'm just going to explain a little more about the geologic timescale for a moment. The biggest time periods, the largest chunk on the scale, are called eons. And there are 3 of them. There's one super eon, And that super eon is the Precambrian period because it takes up the most time. When you look at the geologic time scale, there's this giant chunk when there's no life, and then suddenly there is microorganisms. And those microorganisms at some point jumped and turned into multi-cell life forms, which eventually took over the oceans, and it became the Cambrian. The Cambrian explosion is a pretty cool thing. Google it. Another video, I'll teach you what hallucinogenia is. On a smaller scale, there are periods and era and ages and epochs. Now, that was not actually in order, but mostly what we deal with when we're talking about it are epochs. Most people know epochs better than anything else, and time periods. The Cretaceous, the Jurassic, and the Triassic are all periods, and they're all marked by extinction events. Those particular ones. Now, you may know what those are. Kind of like Jurassic Park, they were marked by the death of dinosaurs. So, where are we now? Are we here? Are we watching here? Or is that the past? Well, generally, geologic time does deal with the past, but right now, we're kind of in this weird moment where we've defined all of the past periods, and so we're here, now, in the present. And we're witnessing the dawning of a new epoch. Epoch? Expoch? Expoch? Epoch. This new epoch is called the Anthropocene. It follows the Holocene. The Anthropocene is marked by the effect of humans and what we do on the earth around us. So the Holocene, which was the previous time period, actually wasn't that long. It was, looks at her notes, 11,700 years. So the Anthropocene, we're actually technically still in the pre-Anthropocene. And it's not even an official epoch yet, but it will be, I assure you. Because these are some of the things that they're observing. In 1945, the Trinity test happened. The Trinity test was a code name for the first atomic explosion that occurred during the Manhattan Project in World War II. It is a world-changing event. It is a time period that changed literally everything, how we interact. It caused the Cold War. It introduced nuclear fallout to our atmosphere for the very first time. And today, scientists have been observing the sedimentation that proves that that is actually a marker of the next geologic epoch. So, in ice cores and lake cores, they have been finding radionodules. Radionodules are tiny particles of radioactive material that have been deposited either through ejecta or through rain, or carried along in the clouds, or deposited in some other manner. But most notably in ice and lake cores, they're finding a layer of sediment that marks the radioactive fallout from that 1945 Trinity test. And so 1945 is the start of the Anthropocene. Possibly. They're still debating it. But it is the most notable point in the recent history that is observable within the geologic record. And after that time, we get everything else. The other things that scientists are looking at, which are terrifying and fascinating, and actually add to the argument that climate change is real, are the fact that we are mining, extracting, and moving around resources all over the world. Metal, oil, and rocks, rare earths, magnets, and other elements that exist in the crust that we walk on and we live on, and slowly is shifting due to tectonic pull, which is another video I should do because tectonics are freaking cool. And geology really distracts me because all of it is fascinating. But so we're taking all of those minerals and materials and we're moving them all over the place. And so they're no longer in situ where we found them, because we're mining and we're digging and extracting and using things like fracking and chemical forms of extraction, which involve acids and other abrasive materials, to pull them out of the earth and then redistributing them wherever the frell we feel like. And those materials are largely not renewable and are, in a geologic time span speaking, not going to be replaced in our lifetime or your children or your grandchildren's lifetimes. They take a long time, or ever. Has anybody ever told you how gold is made? It doesn't involve alchemy or lead. I will tell you this. So gold is made in things like our sun. The sun makes gold. So no, do not plan a Space Force trip to the sun to extract gold. Or do, just put certain people on it. Gold is made through giant, massive nuclear reactions that only take place in stars. So the gold on our planet is not renewable. It's not like our planet is producing more gold as we speak. That just doesn't happen. So, remember those fillings? You have a non-renewable source in your mouth. Lastly, plastics. Plastics are being found everywhere, and scientists are predicting already that plastics will be incorporated into the rock, especially in benthic, cold, deep water environments where there is limited UV exposure that actually partially breaks down plastics. So the plastic is sinking to the bottom of the ocean and then slowly being incorporated into sedimentary rocks that are being created literally as we speak. It's also being found on places like beaches and in fish, everywhere. We're finding it everywhere. And especially in environments like, say, Hawaii. I read a really cool paper about plastics in Hawaii and a study which actually identified a new form of sedimentary rock that incorporates plastics. So, what's that called? Plastiglomerate. Plastiglomerate is a form of rock. It is a sedimentary rock, and it is made from a combination of basalt, coral, and plastic. It can have other variations, including sand and glass and other little bits of things that are found on beaches. Specifically, it has been observed at Camilo Beach. Thank you to Patricia Corcoran, Kelly Jazvac, and Charles Moore for writing that paper. It was fascinating, and your photos were incredible. And if you go and you Google plastiglomerate, you will find some really disturbing photos that involve molten plastic that have been incorporated into sedimentary rocks. So those are the three major observable forms of geologic change that scientists are using to argue that the Anthropocene has already begun. Other terms that go along with this are climate change, invasive species, terraforming. Terraforming sounds like a cool thing, and in theory and in science fiction it is, but what we are doing to our planet is detrimental to our longevity as a species. So terraforming here on Earth is actually a bad thing. It includes things like rerouting rivers and hydrating deserts, which are not supposed to be hydrated, and changing the basic makeup of an environment. Like, say, clear cutting and burning a rainforest and then turning it into a farm. That is terraforming. And in a massive scale, which is what's going on currently, it is actually detrimental to our planet. So the last term, which I find kind of cool, and I also feel like society has failed me a little, is technofossil. A technofossil, which should be a band by now. That's why I feel you've failed me. Somebody do it. I need an industrial band named Technofossil tomorrow, okay? Technofossils are fossils or fossil evidence of humankind, and it includes things like bits of technology, tiny parts of metal that have been created into some form of technology, because all of our things, microphones, speakers, cell phones, are not biodegradable, and for the most part our society has trained us to think everything is disposable. And that's just unfortunately not true. There are places where you can take antiquated technology and have them repurposed or recycled. But on a large, massive scale, we're not doing that. And so these things are going into landfills and being covered up and forming a fossil record of us basically destroying ourselves and the planet. And I don't mean to be so gloomy about the whole thing. We've got a lot of cool science coming out of it. So, no, really, quit fucking up the planet. I mean, it is cool. In geology, we're observing something that we've never had a chance to observe before. And it is really neat that I can do things like this. I ain't no Holocene girl. I ain't no Holocene girl. But I would rather not, kill the planet in the process of creating the Anthropocene, which is kind of a fun word to say. Also, you should support your local aquarium. This is from the Seattle Aquarium. It says otter things. Go out and support science. Visit a museum. Visit an aquarium. Visit a zoo. All your proceeds actually go to studying and preserving and finding ways to make our world a better place. And also, I know there's a lot of political debate about whether this is actually occurring, but guess what? It is. Science says it is. We are changing the planet. But you know what? Politicians might lie. Your parents might lie. Historians might lie. But you know what never lies? The geologic record. Fossils. If you like these otters, if you like what we're doing here, make sure you like, comment, subscribe, click the little bell in the corner so that you get notifications whenever we post a new video. And I'll be doing more of these because, as I said, I get really distracted when I start talking about geology. So now I'm thinking about tectonics and moonquakes and all kinds of crazy things. So you'll be hearing from me again soon. I think I made a funny face on that. Come along while I take you to It was the dawning of the age of Aquarius, the age of Aquarius. Aquarius! No, not exactly. Did you know that most of the methane from cows comes from their mouth, not their ass? I learned that this week and I have to pass it along. It's like The Ring, okay?